Yeah, we are looking at question two. Question one is in previous video. Solve the initial value problem. And you can see we have cos x times sin x minus xy squared, and then plus this y minus ys squared. That's it, y dx. So what we have here, instead of the y dx being distributed across the two expression, we only have it in one place. So what we do now is for us to force it to spread across the two given expression. Okay, multiply 2 by what? Multiply 2 by the denominator, which is dx, multiplied through uh, by the denominator dx. So we now have now cos x sin x, okay, minus xy squared. We have dx here, then plus y minus yx squared dy. Then after this, we can know what to do now. Can know what to do. What we can do now is also look at it very well. Does it conform to the standard form? It does. This is what? This is m. How did I know? Because of what? The x. Okay? The x. This one also, because of the y, I know that this is what? This is n as a function of two variables. And the standard form is that this plus this equal to 0. Okay? If it's equal to 0, then there's a function called f of x. Okay? There's a function called f of x such that uh, such that delta f delta x, okay, which is called m, and what delta f delta y, which is called n. Okay, but that's not where we are going. So since we've already know m, okay, then the next thing to do now is to test for exact. Actually, the question is not asking for exact, just say solve. So we are the one that will know which one, what form does it take, what standard form does this conform to. Okay, so what we now do now is for us to do a test for the exact delta m respect to, you can see it's there. You do it with respect to the other function, the y. And that will be equal to what? Let's look at it. When you are differentiating partially, what you do is to look for where you have y. I have y here. I only have y here. So I'm going to do y, which is equal to 2y. And this one is a constant. So I'm going to have minus 2xy. Okay? So that's that for that. Then the next thing to do is to take the other function n and do that partially respect to the other respect to the other function, this one. Okay, let's look at what we have for n. This is my n. Okay, just look for where you have x and do the implicit partial differentiation. So this is where we have it. Okay, you're only differentiating what? X squared, and this will be kept as what? As constants, and that will give you minus 2xy. So this is what? This is exact differential. This is exact differential because this one is equal to this one. This is exact. Okay, so if it's exact, that's not the end. We still have to go on so that we can get the solution for that given problem. So if it's exact, then there is a function. There is a function f of this. Okay, such that I've already said that such that I can use any of this to continue and get my solution. I can use any of that. So I'm going to use this one such that theta f, theta y is equal to what? Is equal to n. And my n is what? Is equal to y minus y squared. Okay? So it's equal to n. Okay? Then the next thing to do is to integrate partially. Then you have f equal to integral of this minus y squared. Don't forget theta y. Okay? And when you're integrating partially with respect to y, then there must be a constant of respect to, yeah. If it's the y, then your constant will be what? G of x. If it's theta x here, then it will be what? G of y. And this one doesn't matter whether you write dy. So we don't, it doesn't matter. We just want to know the main thing is for you to get it right here. Get the integral partially right. And that's what we need in this place. Okay? So, and that will be equal to, let's look at what we have here. This will be equal to, this is y, y, delta y. Okay? That's good. That means we're having here y squared over 2 for the first one here. For the second one here, minus. Okay? You have y here, so you are taking your s squared constants and you are differentiating this one. You are integrating this one partially. So that's 1. So that's a y squared over 2 times what? Your s squared. S squared could be anywhere. S squared. Okay? Then plus what? Plus g of what? G of this. Okay? So that's the f. That's the f. Let me repeat that again. You are integrating partially. Okay? This is your y. The y. Okay, and you know that generally for integration, this will be the power here is 1 already plus 1. So that's the y squared over 2. Then here, you have two functions. Okay, so what you do, you will not say use a product and you're going to use integration by part or any other methods. No, you just focus on what is the function here respect to y. You're only integrating respect to y. Any other function you have there will be kept as a constant. Okay, and this will now become, I'm only differentiating this one. This will be y squared over 2, and this one will be kept as a constant. That's what we have now. Then the next thing to do is to differentiate partially. Differentiate partially with respect to, what do we have here? Respect to x, so that we can get the value of this. That's our target now. We want to get the value for g of x. Okay, and for you to get the g of x, you must first of all differentiate partially with respect to x, and this will give you delta what? Delta f. Partial differential of f respect to what? Respect to x equal to, and there is an notation that I have. The partial differential of f respect to x is m, and our m is what? Our m is what's our m? Our m is cos x sine x, okay, minus xy squared. That's our no, I said this one, that f respect to x, the differential of f respect to x is automatic, is m. We call it m. Okay, so that's it. That's that. And equal to, do this one, differentiate partially respect to x. So if you do that respect to x, this will equal to this is a constant. Differentiate partially, there's no x variable here, so this one automatically becomes 0. This becomes 0, no x here. So we are only coming back here, and that will equal to minus what? If we differentiate this one, that will be equal to y squared. This one is a constant, but 2. This will give me 2x. So this one will cancel out. The 2 will cancel out. So I now have x y squared. Okay? Yeah. Then plus what? Plus g prime of what? Of x. Okay? So with that, don't forget this is your m. This expression here is your m. Okay? So with that now, with that now we now have g prime of x equal to what? Equal to cos x sine what? Sine x. Okay, that's what we have now. So, and what we now do here is for us to want to get the value of g and g of x, and then integrate both sides. Integrate both sides respect to this function we have here, with respect to what? With respect to x. So if you do that, automatically this becomes g of x. Okay, and this one is now how to integrate this one. That's what we want to do now. So from here, let's this is what we have here now. Yeah, you can substitute for any of the functions. But let's call u equal to cos x. Let's substitute. Let's go for cos x. Okay, so substitute for cos x. Okay, and in that case, we have the u is equal to what? Minus sine what? Minus sine x. Okay, then dx. Okay, then you can make your du. So what we are trying to do is that by the time we substitute back, one variable will cancel to remain 1. Then we now have the u over minus sine x equal to what? Dx. Then you can go back. G of x is now equal to integral of cos x u times sin x is what? Sin x times dx is u over minus sin x. So sin x will cancel out. So I have what? Minus integral of u du. And that will be equal to what? Minus u squared over 2 plus what? Plus c1. And that will be equal to, you can substitute back your u, you can replace back your u, and that will be equal to minus cos squared x over 2 plus c1. Okay, then the next thing to do now is to come back to your f, to this place, and replace your f function there. Replace the f function. f is now what do we have there? Y squared over 2 minus y squared x squared over 2 plus, we have the value is minus what? G of x is minus cos square x over 2 plus c1 plus c1. Okay, and then I told you that f will now become f is definitely, you replace your f with c. So the solution is what? The solution is y squared over 2 minus this minus what? Cos square x over 2 equal to what? Equal to c. Because this one will go to the other side, and so then becomes c, because f is replaced c. Okay, then that's that on that case. So the solution, we have the solution already now. Then we also have the initial, we have the condition. We have some values here. Initial value, we have this equal to 2. Okay, and the essence of that is for us to get the value of c. Okay, it's for us to get the value of c, which will be equal to it will be equal to, this is equal to x, this is y. When x is 2, y is when x is 0, y is 2. When x is 0, y is 2. Let's plug in there. This is 2. This is 2 square. That's 4 over 2. That's 2. This is this one becomes 0. 4 times 0, that's 0. Minus cos square 0. Cos square 0, I think that's 1. That's 1 over 2. That will give you 3 over 2. And that's equal to c. So just go back to this place, the solution, and place back, and that will be equal to what? This minus this minus this over 2 minus cos squared x over 2 equal to what? Equal to c. Okay? Equal to c is 3 over 2, equal to 3 over 2, equal to 3 over 2. So that's the solution, equal to 3 over 2. Yeah, I want to make more clarification on where we have g of x equal to this. There are many approaches you can take to get the integral of this sincerely. We said that in this place we substituted for cos x. You can as well substitute for sin x. The choice is yours. Okay, you can substitute for what do you call it? Cos. You can substitute for what? Sin x. Okay, and if you do for sin x also, there may be variation in the answer. Okay, but that's just a standard method. When you have sin cos, you can substitute for any one of them and use your change of variable. Another way we can solve this g of x is this way. We have integral of cos x sin x dx. Okay, another way we can solve it, we can manipulate our way here and put 2 here. That will be cos x sin x, okay, dx, and put the 2 and cancel that 2 outside. okay, and that will be equal to integral of what sine 2x, because we know that 2 sine x cos x is sine 2x dx, and don't forget the half you have here. So and that will be equal to half. Okay, the integral of sine is minus cos what? Cos 2x over what? Over 2. Okay, integral of sine is cos of that function, and then you now divide your answer by the attachment to that variable, which is 2. So in this case now you have what? Minus 1 over 4 cos 2x. It's possible that you may have different little bit difference of answer, but we're going to see. Okay, but what is important is your steps. Okay, so that's that for g of x. Okay, another way you can also go on for this is to substitute. When you have this, when you have this integral cos x sin x, as I said, that you can substitute for any one of them. When you have sine cos, you can go for any one of them. Let u be equal to what? Let's equal to what? Sin x. Okay, then the u will be equal to what? Cos x dx, and this one will become my sine is what? U, and cos x the u, cos x dx is what? The u, and this will give you u squared over 2. If you integrate u, that will give you u squared over 2. Then you can replace your u back, which is equal to sine what? Sine squared x over 2. So what we need to do now is for us to now go back and substitute back to here the g of x. Okay, maybe I'll go for it. Your f is f of y, and your f of y is equal to y squared over 2 minus y squared x squared over 2 g of x, which is minus 1 over 4 cos what? Cos 2x. That's your g of x. Okay, that's a g of x. That's a g of x. Yeah. I think if I skip, the board has been clean, but that's what I want to just know. That's your g of x, and I didn't put plus c here, plus c1, plus c1, plus c1. Okay, plus c1. Okay, then your f is what? Your f is what? C. Okay, and c minus c1 is still c. So the solution is now y squared over 2 minus this minus 1 over 4 cos 2x. Okay, equal to c. Then we have the condition. We have the boundary condition. X is equal to 2. Y is what? X is equal to 0. Y is when x is 0. Y is 2. So plug in those values. Then you have 2 here. This one will cancel. Then 0 here. Then you have cos 0 here. Cos 0 over 4. Minus 1 over 4 equal to c. So 2 minus 1 over 4. That's 7 over 4. So there may be little alteration in your value of c. Doesn't matter. Your step is what is important. Is what is most important. So c is 7 over 4. Just come back here and put it there. Okay. So that's that. Is authentic. Is proof. You can solve it this way. Okay. So that's just my additional comment on that g of x on how to solve it. It's just basically integration. Okay. So that's that.